Welcome to the DIY Honda Garage channel. This presentation will guide you through the troubleshooting process for the diagnostic trouble code DTC P0979, known as Shift Solenoid Valve C, short, specifically relevant to Honda Civic models from 2011 to 2015. The shift solenoid valve is a crucial component in the vehicle's transmission system. It controls the flow of transmission fluid, which is vital for shifting gears properly. When this DTC is triggered, it indicates a problem with the electrical circuit related to the shift solenoid valve C, and it's important to note that the issue is not mechanical but electrical. This issue could lead to transmission performance problems. Therefore, timely diagnostics and repairs are essential to maintain safe operation of the vehicle. Throughout this guide, we will discuss the symptoms, possible causes, and detailed troubleshooting steps to accurately diagnose and resolve the issue. DTC P0979 indicates a specific fault in the electrical circuit related to the shift solenoid valve C. The shift solenoid valve is responsible for modulating the flow of hydraulic fluid within the transmission, thereby enabling appropriate shifts between different gears. This valve is usually located within the transmission assembly, often near the valve body, which is integral to the gear shifting process. The failure of this solenoid can directly affect transmission performance, leading to incomplete shifts or improper engagement of gears. Since this code is specifically electrical in nature, it eliminates the possibility of a mechanical issue, focusing diagnostics on the solenoid valve circuitry and connections. Understanding the role of the solenoid helps in recognizing how crucial it is for optimal vehicle functionality, as it influences overall drivability. Several possible causes can trigger DTC P0979, and identifying them is essential for resolution. First, there could be a short circuit within the wiring harness connecting the shift solenoid valve C to the powertrain control module, PCM. This can be due to wear and tear, corrosion, or physical damage. Second, a faulty PCM could misinterpret the signals from the shift solenoid, erroneously triggering the fault code. Third, the shift solenoid valve C itself may be defective, leading to irregular performance or an inability to perform its function properly. Thoroughly investigating these areas during troubleshooting will facilitate a more efficient and accurate repair process. Each of these potential issues must be examined to determine the root cause effectively, ensuring a successful outcome. Symptoms associated with DTC P0979 primarily revolve around transmission performance and may include issues such as delayed gear changes, which means the vehicle may hesitate before shifting. Drivers might notice abnormal shifting patterns that can affect their driving experience negatively. Furthermore, warning lights on the dashboard, particularly the check engine light or transmission-related indicators, will often illuminate, alerting the driver of a potential issue. These symptoms significantly hamper the vehicle's drivability and should not be ignored. Addressing these warning signs early by diagnosing the underlying issue will help avoid further damage and costly repairs down the line. It is crucial for drivers to remain aware of these symptoms to ensure their vehicle remains safe to operate. The first troubleshooting step involves problem verification by performing a diagnostic trouble code (DTC) check using the Honda Diagnostic System (HDS). Begin by turning the vehicle's ignition switch to the on position, which activates the vehicle's electrical systems. Next, clear any existing DTCs stored in the vehicle's computer by using the HDS tool. This reset allows for fresh readings during subsequent testing. Following this procedure, test drive the vehicle in third gear for at least 1 second. The purpose of this specific behavior is to allow the system to recalibrate and potentially recreate the fault under controlled conditions. After the test drive, use the HDS to check for any pending or confirmed DTCs. If DTC P0979 is indicated, the failure is duplicated, and you should proceed to the next troubleshooting step. The second troubleshooting step focuses on checking the operational status of shift solenoid valve C. Start by selecting the appropriate option for shift solenoid valve C in the miscellaneous test menu of the HDS. This will prompt the system to communicate with the solenoid and initiate its testing process. Pay close attention during this test for any audible clicking sounds from the solenoid, as this indicates that the solenoid is functioning correctly. If a clicking sound is heard, it confirms that shift solenoid valve C is operational, and you should move on to step 3. Conversely, if no sound is detected, it suggests a malfunction in the solenoid or related circuitry. Properly assessing the operational status of the solenoid at this point will aid significantly in pinpointing where the fault resides before proceeding with further diagnostics. The third step involves an OBD status check to further confirm the issue with the vehicle's transmission. To begin, test drive the vehicle in first gear with the shift lever positioned in drive mode for at least 1 second. This allows the system to assess the performance of shift solenoid valve C under real driving conditions. Utilize the HDS to monitor the onboard diagnostics OBD status within the DTCs menu. If the HDS indicates a status of failed for P0979, this validates that the failure has been duplicated and you must proceed to step 4. If it indicates passed, this suggests that the system is functioning correctly at that point in time, but you may still need to inspect for any intermittent shorts in the wire connecting shift solenoid valve C to the PCM. Should the HDS show not completed, a repeat test drive might be necessary to achieve accurate results. In step 4, you will be performing an internal resistance check on shift solenoid valve C. Begin this process by turning the ignition switch to the lock position, ensuring all systems are powered down. Next, use the HDS to jump the SCS service check line, initiating the necessary diagnostic preparations. Proceed to disconnect the PCM connector C, which typically houses 49 pins, 49P. With the PCM connector now disconnected, it's essential to measure the resistance between designated test points, specifically PCM connector C pin 21, which is green, GRN, and a ground point on the vehicle's body. The goal is to determine if the resistance falls below 13.8 ohms. If the measured resistance passes this criteria, you should proceed to step 5. However, if it does not meet this threshold, it indicates that shift solenoid valve C is functional, and alternative strategies such as updating the PCM software or substituting a known good PCM for further testing should be considered. The fifth troubleshooting step involves checking for any shorts in the wire associated with the SHC line. Start this process by disconnecting the shift solenoid wire harness, which typically consists of an 8-pin connector, 8P. This disconnection is necessary to prevent any interference during continuity testing. With the connector removed, you will need to check for continuity between 2 test points: PCM connector C pin 21, GRN, and a known body ground location. The key objective here is to determine if continuity exists within the SHC wiring. If continuity is detected, it implies there is a short to ground in the SHC wire between the shift solenoid wire harness and the PCM. This will require immediate repair and verification steps to ensure the circuit is functioning correctly. On the other hand, if there is no continuity, it suggests that the SHC wire is intact, thus prompting you to proceed to the next troubleshooting step. In the 6th step, you will focus on a final assessment of shift solenoid valve C. Conduct a thorough test of the solenoid valve to confirm its operational status. Should you find that shift solenoid valve C operates correctly, this indicates that it's functioning as intended, and thus, the next immediate step will involve replacing the shift solenoid wire harness to eliminate any potential wiring issues before verification. In contrast, if the solenoid fails the test, it will need to be replaced outright. This decision will help ensure reliability and performance in the vehicle's transmission system. Regardless of whether you're replacing the harness or the solenoid, remember to conduct repair verification following any corrective action taken, as this is crucial to confirm that the original fault has been resolved. The last step in the troubleshooting process is final repair verification to ensure the issue has been adequately addressed. Begin by reconnecting all previously disconnected connectors, ensuring they are secure and properly seated for reliable operation. After reconnection, proceed to clear the DTC using the HDS, eliminating any previous fault codes that may linger in the system. Start the vehicle with the shift lever positioned in park, P, and allow it to idle for at least 1 second to facilitate an accurate assessment of the system. After this, conduct a test drive in third gear for a duration of at least 1 second to check the system under operational conditions. Finally, monitor the OBD status through the HDS for DTC P0979. If it displays as passed, it confirms the repair process is complete, and if any other DTCs are present, further investigation into those codes will be necessary to ensure comprehensive vehicle functionality. Preventive maintenance plays a pivotal role in minimizing future occurrences of DTC P0979. One essential strategy involves regularly inspecting the wiring harnesses related to the shift solenoid valves, looking for signs of wear or damage that may lead to electrical failures. Additionally, monitoring the condition of the transmission fluid can help prevent mechanical issues that may indirectly affect electrical components. Ensuring that the transmission fluid is clean and at the correct levels can significantly enhance overall performance. Moreover, one cannot overlook the importance of keeping the powertrain control module, or PCM, software updated. Ensuring the PCM has the latest programming helps optimize communication with the shift solenoids and other vital components. This proactive approach can enhance vehicle reliability and performance, while also extending the lifespan of critical systems. In conclusion, understanding DTC P0979 and its implications is critical for any Honda Civic owner spanning the 2011 to 2015 models. By following a systematic troubleshooting process, technicians can effectively identify and resolve the issue related to shift solenoid valve C, ensuring the vehicle operates smoothly and reliably. This thorough approach mitigates the risk of overlooking potential electrical faults within the vehicle's transmission system. Implementing preventive maintenance strategies further aids in prolonging the life of the solenoid and the transmission as a whole. Continuous vigilance over warning signs will significantly contribute to maintaining the vehicle's integrity and performance. Addressing these issues promptly not only enhances the car's operation, but also ensures safety and reliability for all its occupants. Please like and subscribe to the channel. See you next time.